For this problem, we're going to need to apply the method of sections. The question is asking us to find the member forces in BC, CH, and HI. So let me note that on the diagram. BC, that one black. Okay, there we go. BC, CH, and HI. Well, using the method of joints, you have to solve for each one of these member forces and work your way up, or from the right side, work your way up to the left side. While using the method of sections, we just need to break down this point into a section. And if the whole truss is in equilibrium, then all joints should be in equilibrium as well. And if all joints are in equilibrium, then we can cut sections of the truss, and the sections of the truss must be in equilibrium as well. So in order to solve for this, we can either cut to the right side, or to the left side. But looking at this, it looks like it will be easier to cut to the right side of the diagram. So cutting this to the right side, we will then have forces, which are the member forces. Let's see how I can. Okay. Okay. We will then have member forces here. This would be FBC. There was one going down. FCH. And also one to the right. FHI. So in order to solve for FHI, well, these two forces here are from the same point, and this is just a single one alone. We can do the sum of the moments about C equals to 0. So sum of the moments about C, equals to 0. That means 0 is equal to negative 1,000 going down times 10 feet. Now that's 15. We were told that each one is 5, so 5, 5, 5, 15. The second one is 10 negative because it's going in a clockwise direction. And then we have FH here, FHI, a distance of 5 as well. And this is also going in a clockwise direction, so this will be negative. So subbing for FHI here, we have 5,000 kips, or pounds rather. It's 5,000 pounds, which is equals to 5 kilopounds. That's negative. And since this is negative, this would be 5 kips in compression. Now we can also solve for FBC because these two forces here will be acting on the same point of action at H. So doing the sum of the moment at H, these two force members here will cancel out, and that will leave us just with FBC. So here we also have the same forces here again, negative 1,000, distance of 15, negative 1,000, distance of 10, and we have FBC now, which will be positive because this is going in the counterclockwise direction at a distance of 5 feet. So solving for FBC gives us 7,000 pounds, which is the same as 7 kilopounds. And since this is positive, this will be in tension. Now we can solve for, well, we solve for FBC, FHI. What is left is FCH. Well, here we can just sum up the forces in the y direction, or x, whichever one. Well, I'm going to use the y one. So sum of forces in the y direction, assuming alpha is positive, is equal to 0. So here 0 equals to where there were two forces going down, negative 1000, negative 1000 here. So negative 1000, negative 1000. And where is CH? Well, CH, we assume the intention always away from the point. So this is negative 1 over square root of 2 because of this is a 5 by 5. So this is 1 square root of 2. So going down, we have negative 1 over square root of 2 FCH. Solving for FCH, well, this is 2000. So move that to the other side. Then multiply both sides by negative square root of 2. That gives us FCH as negative 2000 square root of 2 in pounds. So where's my calculator? Okay, that gives us negative 2008 pounds, which is equals to 2.83 kilopounds. If we divide by 1,000, 1 kilo is 1,000. And then the negative just means this is also going to be in compression.